The problem statement from GATE Physics 2012 reads as follows. The value of the integral e raised to the power 1 by z dz over a contour C, where C is the contour of a circle with unit radius mod z equal to 1. The value of the integral is. This is a multiple choice question with one correct answer, and we are required to find the correct one. But first, let's have a quick look at the Cauchy's residue theorem, which can be used to evaluate the integrals of the kind that we see in the question. So the theorem states that if we are given an analytic function fz, so this function is analytic inside this contour C, except at finite number of points, so we call those points singularities. So this fz is analytic at all the points except for these n purple points, which we call the singularities. Then the integral of this function fz over this closed contour C can be given by 2 pi I and sum of all the residues evaluated at the singularity points. So, but now the next question then arises, how do we evaluate the residues at these singularities? So we can evaluate the residues using two approaches. First one is the limit approach, which is beneficial when we have simple poles. And second thing, the second approach is the series expansion, which we use typically for exponential functions or trigonometric functions. Right, so now we'll try to apply the Cauchy's residue theorem in order to evaluate this integral. So first we'll check whether the function that is fz, which is e raised to the power 1 by z, is it analytic or not inside this contour mod z equal to 1. So we can see that this function is analytic. It is a well-behaved function, not exactly well-behaved because it has a singularity. So we write the singularity. So where is the singularity of this function fz? So singularity lies at z equal to 0. You can see if you put z equal to 0, this function blows up. So I'm marking this singularity over here. And it just so happens that the singularity falls inside the contour that we are interested in. And we have seen that in the last slide, that we can write that integral, such an integral of an analytic function which contains some finite amount of singularities, this can be written as 2 pi I sigma k equal to 1 to n, where n are from k is the singularities, and we can write residue fz at z equal to zk. So we take the sum of all the residues at the singularities. So in this problem, the singularity is falling inside the contour. So we only are interested in those residues. So now I can simplify this, writing 2 pi I, right, sigma k equal to 1 to 1. Note there is only one singularity inside the contour, so value of n becomes 1. Then this becomes residue fz at z equal to zk. This is what we need to evaluate. So this can again be written as 2 pi I. So there is only one point, so we can drop this sigma. Residue of fz at z equal to 0. So we just need to find out this second term, residue of fz at z equal to 0. So let's try to do that. We have seen that there are two approaches of finding the residues. One is the limit approach, second is the series approach. So since we know that fz is an exponential function, and we can easily expand it in terms of series. So I'll try to do that. So I'll try to find that residue of fz at z equal to 0 is equal to coefficient of 1 over z minus 0. Why z minus 0? Because 0 was the singularity in expansion of fz around z equal to 0. So we'll try to expand fz around z, the point of singularity, which is z equal to 0, and then we'll try to evaluate the coefficient of 1 over z. So I'll write it. This residue will be equal to coefficient of 1 by z in expansion of fz around z equal to 0. So we know that expansion. So that is 1 plus 1 over z over 1 factorial plus 1 over z whole square over 2 factorial plus 1 over z whole cube over 3 factorial, and so on. and so we are required to find the coefficient of 1 by z in this expansion. So if you see the coefficient of 1 by z, which is nothing but 1 over 1 factorial, so this is coming out to be 1 over 1 factorial, which comes out to be 1. So we find the residue of this function fz e raised to the power 1 by z at z equal to 0 is 1. So I can plug this value over here. So this comes out to be 2 pi I into 1, which is equal to 2 pi I. So we have evaluated the value of this integral. So let's get back to the question, and we have obtained that the residue, the value of integral was 2 pi I. So option D matches, and this is the correct option. Thank you for listening.